Okay, welcome back to Mr. Hassan's Maths channel. I'm now answering a question from an old C34 paper from January 2015. This actually is related to the P4 syllabus about vectors. And this question I gave to my students in an exam, and one of them wants me to answer it. Now it says, with respect to a fixed origin O, the lines L1 and L2 are given by the equations as follows, where lambda and mu are scalar parameters and p and q are constants. Okay, so lambda and mu, they can change their value depending on where the line is, but p and q here are constants, which we're going to obviously have to find. So it says, given that line 1 and line 2 are perpendicular, show that q equals 3. So this is one of those show that questions where they have given us the value of q, so you have to be extra careful in showing your steps to get the full marks for the question. So what we have to state is our reasoning. We must state our reasoning. We can't just show some working and not give a reasoning. Now what we know is, okay, if vector A is perpendicular to vector B, okay, then we can say that the dot product of A and B is equal to 0. That is the principle that we're going to use. When you have two vectors that are perpendicular to each other, okay, which are right angles to each other, and this is good enough for you to show you don't have to write the words. That means perpendicular, right angles. If vector A is perpendicular to vector B, then the vector A dot product with vector B is equal to 0. So we'll say let vector A be now, and let vector B be what? Now what are those vectors? Okay, we've got to decide what vectors, what part of these these position vectors tell us about the direction of line 1 and line 2. So if we dissect the meaning of the equation, the vector equation of the line of these two vectors, well, the part that's without the scalar parameter, this is the position vector of a point on the line. Any point on the line. It's a position vector of any point on the line with respect, of course, to the origin. And this vector here is the direction vector. Okay, so the first vector will take you from O, the origin, to the line. Okay, so say that's the line. So the first vector would be like, for example, taking you from O to that line. That would be this part. And this would be the direction vector. So this would be like a direction along that line, -2, 1, 4. That would be, for example, from there to there. So direction on the line. And then where you end up on the line depends on what the value of lambda is. If lambda is 0, you'll end up at this point. If lambda is 1, you'll end up over here. If lambda is 2, you'll end up over there, and so on. If lambda is -1, you'll end up back there. So the part of the vector which helps us to determine the direction of the vector is the part that is multiplied by the scalar parameter. So these parts are the parts that tell us the direction of these two vectors. So I know that the dot product of these two vectors has to equal 0. So A is the vector -2, 1, 4, and B in my work here is Q, 2, and 1. So I'm going to find the dot product of those two vectors, and then they should be 0. So -2, 1, 4 dot product with Q, 2, 1. We know that it has to equal 0. So now we can multiply, to find the dot product, you multiply the I components, so you have -2 times Q, then you add together the product of the J components, which is 1 times 2, then you add to that the product of the K components, which is 4 times 1, and you know that that has to equal 0, so we can say 6 equals 2Q, therefore Q is equal to 3 as required. We had to show that. So there's the answer to part A of this question. Okay, so we have to be very clear to have this. Okay, this statement should be there. Okay, this statement should be there, either at the beginning or at the end. You could say, as the dot product of these vectors was 0, therefore they are perpendicular. Okay, so that's very important for you to have that statement, either in words or these symbols. It must be there in these kind of questions which says show that, especially when they gave you the thing that you need to show. All right, so now for part B, it says, given further that line 1 and line 2 intersect at the point X, find the value of P and the value, just the value of P first, And then I think the next part says where they intersect. Yes, the coordinates of x where they intersect. So we now know that q is 3. So this is 3. So that's what we can fill in here. So I'll just get rid of this and replace it with 3. So we know that's 3 now. So we can use that as 3. All right, now, so we need to find the value of p given further that they intersect at the point x. Okay, so we know that they intersect at a certain point. So we need to find the value of p. So that we definitely know that these two lines intersect. Okay, we definitely know that these two lines intersect because they tell us, the question says they intersect. So if they intersect, then there's definitely a value of lambda and a value of mu which takes them to the same point. There'll be a value of lambda and mu which takes them to exactly the same point. So therefore, I can just make an equation. I can say 14 minus 6 minus 13 plus lambda times minus 2, 1, 4 is equal to, there will be somewhere where these are equal. P negative 7, 4 plus mu times 3, 2, 1. So from this we can derive three equations. We can have 14 minus 2 lambda. 14 minus 2 lambda is equal to P plus 3 mu. Let me just make that a bit neater. 14 minus 2 lambda is equal to P plus 3 times mu. And then we have negative 6 plus lambda is equal to minus 7 plus 2 times mu. Then we have negative 13 plus 4 lambda is equal to 4 plus mu. So we have three equations here that we can use, and we can find the value of p if we know what lambda and mu are. If I know what lambda and mu are, I can replace the lambda and mu with what they are, and I can then find what p is. So I need to find what lambda and mu is. Now I have three equations here. So I'm going to choose the second two equations, the second and the third equation, in order for me to find what mu and lambda is by using simultaneous equations. So what I'll do is I'll take the first equation, the number 2 as it is, and I'll take equation 3 and multiply it by 2 so that this becomes the same coefficient as that. So I'll take equation 2, okay, and which is negative 6. Let me just change that to negative 6 plus lambda equals negative 7 plus 2 mu. And I'm going to take equation 3, but I'm going to multiply it by 2. Okay, so this is equation 3. Let me make that a bit clearer. This is equation 3. I'm going to multiply it by 2 so that this becomes 2 times mu. So I have negative 26 plus 8 lambda equals 8 plus 2 times mu. Negative 26, 8, 8, 2. That's right. So now what I'm going to do is I'm going to take these two equations, I'm going to subtract them. I'm going to subtract them this way. That way this will cancel out. I'll have negative 26 plus 6. That's going to be negative 20. 8 lambda plus lambda, minus lambda, sorry, which is plus 7 lambda. 8 minus 7, which is 8 plus 7, which is 15. 2 mu minus 2 mu is 0. So I end up with this. I've just subtracted upwards instead of downwards. I could have easily subtracted downwards as well, in which case I would have got 20 and minus 7 lambda equals minus 15. And I would have then got the same thing at the end, but I'm just doing it this way. So now that means 7 lambda is equal to 15 plus 20, which is 35. Therefore, lambda is equal to 35 over 7, which is 5. So I now know what lambda is. Therefore, I can find what mu is. So I can, for example, use equation 3, which is easy to use. I can put lambda as 5. So I have minus 13 plus 4 times 5 plus equals 4 plus mu. Okay, so I have minus 13 plus 20. That's going to be 7. Minus 13 plus 20. Minus 13 plus 4 times 5. Yeah. Yeah, minus 13 plus, that's 7 equals 4 plus mu. So 7 minus 4 is equal to mu. Therefore, mu is equal to 3. Yep, that's right. Minus 13 plus 4 times 5. Yep, okay. So there we have our answer for lambda and mu. So lambda is 5 and mu is 3. So now we have to find what p is. Okay, so now I can use this first equation. I can take equation 1 and I can say 14 minus 2 lambda equals p plus 3 mu. So now I can take my value of lambda, which is 5. So 14 minus 2 times 5 equals p plus, and this is 3 times 3. So 14 minus 10, which is 4, equals p plus 3 times 3, which is 9. So therefore p is equal to 4 minus 9, which is negative 5. So I've now found the value of p after all that. Alright, so to find the value of p, we had to do what? Well, we had to first of all make these equations from the fact that these are intersecting, so there will be a value of lambda and mu for which they intersect. We found that value of lambda and mu from the two equations we formed from the things that we know, and then we use those two values of lambda and mu to put into the equation for the I component, which is the part that's missing, which we have to find p, and then we could find what p is. So there's the answer for part B of this question. Now it says find the coordinates of x. Well, we can use either of these two equations to find the coordinates of x, because we know when lambda, because the point where they intersect is when lambda equals 5 and also when mu equals 3. So when lambda equals 5, if I put that value in here, this will give me the place where they intersect, which will be x. If I put mu equals 3 in here, it will also give me the point where they intersect, which will be x. Now, I think it's safer to use lambda as we have already got, in case we made a mistake, for example, finding this. Here, the only thing that we don't know is lambda, and if we got that part right, we're going to get the next part right as well. So it's much safer to use the first equation because we have everything else in it already. Here there are, we know that's 3, but p, for example, we had to find is negative 5. This is 3, we know already from the first question. They told us that anyway, but p we had to find, okay, is negative 5. And if we got that part wrong, then we will get of course, the next part wrong. So to find the coordinates of x, I would personally use the first equation, although if you did everything correctly so far and you use the second equation, you would still get the marks for it, no problem. But if I take line 1, and be very careful that you don't mess up with negative signs. It's a very common mistake. So 14 minus 6 minus 13. So 14 minus 6 minus 13, that's r equals, plus, and you got lambda times negative 2, 1, 4. Lambda times negative 2, 1, 4. Okay, make sure I haven't messed up minus signs anywhere. That's all right. So we know that at x, lambda is equal to 5. So we can say that the position vector of x, we can say O to x, therefore, is going to be 14 minus 6 minus 13 plus 5 times negative 2, 1, and 4. That's going to give me 14 minus 10, which is 4, minus 6 plus 5, which is negative 1, and minus 13 plus 20, which is 7. So we can say, therefore, they want as coordinates, so we should give it in coordinate form. So x is going to be 4, negative 1, 7. If they said find the position vector of x, we'd give the answer like this. If they say find the coordinates, we write it in coordinate form. So this is the answer, 4, negative 1, 7. That's the answer for part C of this question. Now on to part D. Now, part D says the point A lies on line 1 and has position vector 6 minus 2, 3. Given that the point B also lies on line 1 and that the vector A to B is twice the vector A to X, find two possible position vectors of B. So this is the information we have so far. We know the position vector of X. We know the coordinates of X, therefore its position vector will be 4, minus 1, 7. We know the equations of line 1 and 2. We know the numbers that we're missing in it now. All right, and we know there's a point A that lies on line 1. So let me make a little sketch. It's always good to sketch these kind of problems to give you an idea of what's going on. So I'm going to draw a line. I'm going to think of that as line 1. There's another line which is line 2, which I know they are perpendicular. We know that, and they meet at X. So there's a right angle between them. This is the point X, which has the coordinates 4, minus 1, 7. So we worked that out in the last part of the question. Okay. So let's call this line 1 and let's call this line 2. All right, now they told us the point A lies on line 1 and has position vector 6, minus 2, 3. So let's say, for example, this is the point A. This is 3-dimensional, so it's very difficult for us to draw it accurately. So we just put things anywhere for now. 6, and we got minus 2, 3. Let me make it a bit closer up there. 6, minus 2, and 3. That's the position vector of A. Okay, so that means the coordinates of A is that. All right, then it says the point B also lies on line 1, and given that point B also lies in the same line, so somewhere along this line, and A to B is twice A to X, find the two possible position vectors of B. So from A, the distance of B is twice A to X. So for example, I could take this distance here. Okay, that's the distance A to X, and I could go another distance of that much this way. So that would be 1 A to X, 2 A to X. So B could be at this point here. That's one possible position for B. I'll call that B1. And the other possible position for B, if it's on this line, well, it has to be on the other side of A. So you can go 1. Okay, so that's 1. And then from there, another 1. Okay, so the other position vector that B could possibly have is somewhere over here. So I'll call that B2. All right, so those are the two possible positions of B. You've got one here and one here. Okay, that distance is twice AX. That distance is also twice AX. So we want to find the position vectors of B. So let's just say the origin is somewhere here. We can put it in a random place for now, as we can't draw this accurately as it's a 3-dimensional vector. So I know the position vector of X. I know the position vector of A. And I need to find the position vectors of these 2 points. Okay, I need to find those. That's what I need to find. This and this. Okay, now, I know if I want to go from O to B1, I can go from O to A. And then I can go from A to B1. Plus A to B1. Okay, and if I want to go from O to B2, I'm going to go from O to A, and then I'm going to go from A to B2. Now, what do I know about A to B1? Okay, from A to B1, we can say that A to B1 is twice the vector A to X. It's twice the length of A to X and in the same direction. So we can say A to B1 is equal to 2 times, okay, A to X. So we've got to find what A to X is now. And we can also say A to B2, okay, A to B2, from A to B2 is like A to X, but the opposite direction. So it's minus 2 A to X. Okay, so it's minus 2 A to X. So I need to find, for both of them, I need to find what A to X is. So we've got to find what A to X is. If I find the vector from A to X, that's the key to this question now. So if I want to go from A to X, I've got to go A to O and O to X. Okay, I've got to go A to O and O to X, which is the same thing as saying minus OA plus OX, or you can say OX minus OA. And we know O to X is, its position vector is 4 minus 1, 7. So you can write this as 4 minus 1, 7 as a position vector, minus O to A, which is 6 minus 2, 3. Let's see we didn't make any mistakes in copying them down. Okay, good. So now that's going to give me 4 minus 6, which is negative 2, minus 2 plus 2, which is 1, and 7 minus 3, which is 4. So that's the vector that takes us from A to X. And we can see that 2 times A to X is going to be the vector minus 4, 2, and 8. 2 times this, minus 4, 2, and 8. So therefore we can say the vector from O to B1, okay, is a vector from O to A plus 2A to X. Okay, so O to A was 6 minus 2, 3. So this is going to be 6 minus 2, 3 plus, and 2A to X is minus 4, 2, 8. Okay, so that's going to be 6 minus 4, which is 2, minus 2 plus 2, which is 0, and 3 plus 8, which is 11. And the question says coordinates or position vector. Okay, position vector. So we can say that one possible one for B, say O to B1, is 2, 0, 11. And then we can say O to B2 is O to A minus 2 times A to X. Okay, so it's going to be the same things here, 6 minus 2, 3. But instead of plus, you'll have minus negative 4, 2, 8. 6 minus minus 4 is 10. Minus 2 is minus 4. 3 minus 8 is minus 5. Okay. Minus 4, 2, 8. So 6 minus 4, 6 minus, that's 10. Minus 4, 3 minus 8 is minus 5. And there's the answer. So that's O to B2. It's going to be 10, negative 4, and negative 5. So OB1 is 2, 0, 11. OB2, 10 minus 4 minus 5. Those are the position vectors of B. The question tells us to give them as position vectors and not as coordinates. If the question said coordinates, then we'd write them as coordinates like 2, 0, 11 in this form, and so on. But no, the question doesn't say that. So we give this as a position vector. O to B1 and OB2, those are our two answers. It's a good idea to maybe highlight that those are answers in the end. And that's it. That's the answer to this question. Other questions from this particular paper from the January 2015 C34 exam can be found in the playlist that should appear over here at the end of the video. Other questions from the practice paper that I took this, or I put this question in, can be found in the playlist that will appear in this area. And you can watch other vectors questions from P4 in the playlist over here, and you can subscribe to my channel by clicking on the link. Thank you for watching, and see you soon.